Yes. State the meaning of the uniform circular motion. What's your answer?
The meaning of uniform circular motion is when an object goes in a circular motion without a change of speed.
Okay, you will confuse if you say the answer. I'll tell you an easiest way how to say the answer. Okay?
Okay, sir.
What is circular motion? If an object travels circularly, call it as a circular motion. What is uniform motion? If an object travels equal distances in equal intervals of time, call it as a uniform motion. We separated two now. Uniform motion. If an object travels equal distances in equal intervals of time, that is uniform motion. Uniform circular motion. If an object travels equal distances in equal intervals of time circularly, called as uniform circular motion. Very simple,
Yes.
right? If an object travels equal distances in equal intervals of time circularly, you can add it. Okay, circularly called as uniform circular motion. Yes. In your method, if you explain, generally I'm also will be confused. Separate the words there. Uniform motion, circular motion. Circular motion, every child know that. An object travels circularly called as circular motion. Uniform circular motion, which means uniform motion if an object travels equal distances. First 1 kilometer, 1 second. Next 1 kilometer, 1 second. Next 1 kilometer, 1 second. This is the division what we studied. Equal distances in equal intervals of time. Just add it circularly. Definition is over. Uniform circular motion. Clear? Oh.
Yes, sir.
Yes. Next question. Just to clear that. Yeah. Why is the motion of an athlete moving along a circular path an accelerated motion?
Because acceleration means the change of speed, right, sir? Then
Changes of a direction you should think.
change of direction, sir.
Yes. See, generally, simple example I'll tell you. You are, you know how to ride the cycle?
Yes, sir.
Cycle riding. You sit on a cycle and little bit you do pedals. Lightly it will be moved. Both pedals, your legs are there.
Yes,
Don't
sir.
pedal it further. Just your handles you move up and down. You can move the handle. What will happen? Slowly, automatically, cycle started to move. Have you practiced this in your practical life?
No,
if
sir.
you sit on a cycle,
Slowly, sir.
If you sit on a cycle, little bit you pedal it, balance the cycle, don't touch your feet to the earth, both the legs on both the pedals, little bit slowly you are moving, then almost stopping condition what you can do, handles you can do like this is the way. Don't do totally handles, little bit handles you can do. Then automatically cycle starts move. Similar way, horse race, running, all the paths of running paths are the circular path only. Yes, why that is the circular path? Which means in an athlete while running, why they are moving in a circular path? At a circular path, each and every point the direction is changing.
Yes, sir.
Whenever each and every point direction is changing, automatically it is an accelerated motion.
Yes, sir.
How to write the sentence now? How to write the sentence?
Acceleration
in a circular path. In a circular path, each and every point.
Okay.
Sorry, at each and every point.
Yes, sir.
The direction is changing. The direction is changing. Hence, athlete get accelerated. Got the point? This is the way the word construction will be. In a circular path,
But
at each and every...
in an athlete, sir, in some races they have the thing going in a straight motion also, sir.
But always it never be the straight line motion, right? Straight line motion, when they will put, if there any observation, who is coming first? While in a circular motion, we can't decide who is first. That angle won't be determined correctly. If sometime, some distance of 100 meter or 50 meter or something, they'll put it in a straight line, then we can understand who is the first, crossing the border. In a circular path, what will happen? It's very difficult. Circular path is, there's no meaning of straight line. Yes, na?
Yes.
For example, simple example I'll tell you. There are the racks over here. A person is coming here, one person is coming here. Who is the first? We can't decide. Let them put it on a straight line. Who is coming first, we can easily decide. Yes, na? One is big circle, other one is small circle. So the distances between the athletes are, some distance will be there. That's the reason straight lines they'll put it. Hope you got the answer.
Yes, sir.
These are all the CBSE questions. Next, let me clear the diagrams. Yes. State the type of a motion represented by given graph.
Okay, sir.
Hello.
Yes, sir.
I guess your camera off? Yeah. State the type of motion represented by the given graph. Distance time graph this is.
Yes, sir.
What kind of answer you can give?
State the motion represented by the given graph.
Yes.
Distance time graph. No, sir. In the distance time graph,
How the graph will be?
The screen share just is coming fully blurry.
Now?
I can't see it, sir. It's not coming, sir.
Okay, maybe. Because I put that in a slide mode, it's not coming. It's okay, fine.
Now it's better, sir. Now it's coming.
Yeah, that's fine.
So in this distance time graph, you would get to know the amount of distance traveled by an object in how much time, right, sir?
Yes, that's called as a distance time graph. They given this is the way. This graph indicates. This graph indicates. I explained in the class. State the type of a motion represented by the given graph. Fine. If you forget, no problem. I'll make you remember. What is uniform motion? If an object travels equal distances in equal intervals of time, uniform motion. What is non-uniform motion? If an object travels non-equal distances, non-equal intervals of time, non-uniform motion. Now this graph, once you can see equal intervals of time and equal distances, right? Between these two here, between these two here, between time and the distance, this is here. What kind of motion it is? Uniform motion.
Uniform motion.
This graph represents uniform motion. Clear? And what is the non-uniform motion graph? There is something curved. Yeah, there is something curved. Distance time graph. And the graph of rest, an object at rest. What kind of graph? Distance time graph parallel to time t. Distance time graph parallel to time t. This is at rest because time is increasing. Displacement is 0. Where you parked the bus, once you can remember our class, we parked the school bus in a school campus from morning 8:30. Up to 3:30, the position won't be changed because bus is at rest. So the distance is common, time is increasing. So this graph indicates an object at rest.
Yes, sir.
Yes? All right. Next, I'll go for the next question. Yes. If the acceleration of the particle is constant in magnitude but not in the direction, which type of path does the particle follow?
The acceleration of the particle is constant in magnitude but not direction. So isn't this vector? It's not vector. What is the other name?
Which one? Which one?
Scalar quantity.
Which one?
Scalar quantity, right?
They're not asking about scalar or vector. We no need to mention anything about the magnitudes or the directions over here in the form of scalar and vector. Question again, read properly. If the acceleration of the particle is constant, acceleration is constant in magnitude.
In
Yes,
magnitude.
acceleration value is constant, but not in direction. Not in direction in the sense of object is moving forward direction. Absolutely, acceleration also forward direction, right? A bus started, which is moving east direction. Movement also east direction, speed also east direction, acceleration also east direction.
Yes, sir.
But there is a particular moment is there. An object acceleration is different than the object movement.
Okay.
What it is? What type of path does the particle follow?
Particle follow.
Yes, this also we discussed. I'll tell you. You are throwing object. You are throwing object in forward direction, like top direction. Throw a stone top direction. Yes,
Yes.
stone will be go top direction only. But acceleration due to gravity will be down direction.
Yes, sir.
G is equal to 9.8
Hmm.
meters per second. Sorry, meters per second square. Acceleration. Object moving top direction, acceleration will be down direction.
Yes, sir.
Now, how to write the answer? If an object moves upward direction, acceleration of an object will be down direction. That's it. If an object moves top direction, acceleration will be down direction towards to the earth. Yes, no? Understood the fourth question?
Yes, sir.
Can you give another example?
So when you're playing a game of football, when you're kicking the ball up, then the acceleration will be downwards.
Only up to top direction. If ball comes down direction, again it will be changed. If you kick a ball, if the ball moves top direction only, which is example is correct. If the ball comes down, again it will be wrong.
Yes, sir.
Yes, no? Fine.
But again, if it comes down, it will be wrong. But that
Same
way
direction only. Acceleration, movement, both are in same direction. Next question. Next question. Yes.
First one, the body is at rest, sir. Second one, the body is not in any uniform motion.
First
Hello,
one.
sir?
First one. First one.
It shows when the body is at rest.
Excellent.
Second one it shows when the body is not in a uniform motion.
No, no. We should not say uniform motion. Some extend way uniform motion, then at rest.
Yes, sir.
Because sometime it is going to uniform motion only, right? Then it came to
Yes, sir.
rest. That answer we should give.
Hmm.
Next, the direction in which an object moves is given by the direction of velocity of an object and not by the direction of acceleration. Give an example to justify the statement. Read properly, I won't say this answer. Already we said now what it is.
The direction in which an object moves is given by direction of velocity of an object and not by direction of acceleration. Give an example to justify the statement. So, like the stone example, no, sir.
Excellent. The stone example only. Stone example only. Stone, if it is throws top direction, velocity is in the top direction,
Yes, sir.
acceleration will be down direction.
Hmm.
Yes. Next.
Yes, sir. Direction of rotating objects in the direction in which in which an object moves is given by the direction of velocity of an object and not by direction of acceleration. Give one example to justify the statement. Once again, let me understand this.
1 minute, 1 minute, 1 minute.
Okay, sir.
1 minute. There is a small wrong over here. I'll correct this slide later. Go for this question. The velocity of a particle moving along a straight line in a certain time interval as shown in below. What is the distance traveled during acceleration?
Velocity equal m by s. This is velocity time graph, sir.
Yeah, velocity time graph. But what they're asking, what is the distance traveled during acceleration?
Acceleration. So I didn't understand this question very well, sir.
Okay. Velocity time graph, you saw that.
Yes, sir.
Yes. Velocity time graph indicates what?
The velocity of an object.
Velocity time graph indicates which parameter? Acceleration, right?
Yes, sir.
Because acceleration is equal to velocity by time.
Hmm.
Velocity by time is equal to acceleration. So this velocity time graph, whatever, it will give the acceleration. But in the diagram, you can see there is a line over here, up to here, and here. So where is the acceleration is very more? At this point, right?
This point, yes,
So
sir.
this point here, velocity 10. Time will be 1 second. So what is the distance traveled by an object? Velocity is equal to displacement by time. Displacement
Okay.
nothing but distance.
Hmm.
Yes. Now the displacement or the distance is equal to velocity into time. Velocity how much here? 10 meters per second.
Into
Time
1.
how much here? 1. So what is the displacement or the distance? 10 meters. That's it.
1 second, sir.
Yeah. Any doubt?
No, not doubt, sir. I'll just copy this down.
Okay. Okay. Please note it down.
Yes, sir.
Got the point?
Yes, sir.
Next, hope you understood how to calculate the distance. If any graph comes also, velocity time graph or any other distance time graph, you should understand what is distance by time?
Distance
Speed.
by time.
Speed. Yes. Velocity by time? Acceleration. So there only the numericals will be there. Next question. Yes. This question. A bus decreases its speed from 80 km per hour to 50 km per hour in 4 seconds. Find the acceleration of a bus.
Sorry. One second, sir. One second, sir. I think so.
Yes.
I know this answer.
Yes, because we solved it before.
U is
I'll tell you how to write it, how to do that.
yes, sir.
A bus decreases its speed from 80 km per hour to 50 km per hour in 4 seconds. So whenever the question, if you see, write that given data.
Okay.
What is given data? Initial velocity, how much?
Initial velocity is 50.
No, 80 km per hour. Decreases the speed from 80 to 50, right? This
Yes,
is the
sir.
initial velocity, this is the final velocity.
V minus U by
80 km per hour. What is the final velocity?
50.
Very nice. 50 km per hour. Now what they gave? Time also they gave.
Second.
4 seconds.
4 seconds.
What is required data?
Required data, sir.
Yes.
Required data, they want to know the acceleration of the bus.
Yes. Required data is acceleration. Now, what is the formula?
Formula, the acceleration is V by T. Should be 4
Again,
by 8.
again, for, acceleration is equal to,
V by T.
but both V's are there here. Initial velocity, final velocity. What you can do?
V minus U by T.
Hmm?
V minus U by T.
Yes, final velocity minus initial velocity by time. This is formula. But here, velocities are in kilometer per hour. Time will be in seconds.
Okay.
So, kilometer per hour, how many seconds? How many minutes per second? 1 kilometer per hour, how many minutes per second?
How many meter? 1 kilometer
Per hour, how many minutes per second? 1
So,
kilometer, how many meters?
1000.
1000 meters. Yes, 1 kilometer, 1000 meters. 1 hour, how many seconds? 3600 seconds.
Now 3600 seconds. Okay.
Yes, now 1 hour, 3000 because 1 minute, 60 seconds, 60 minutes, 1 hour. So 60 into 60, 3600 seconds.
Yes.
Now, cut by 20 over here, 5 by 18. So finally, 1 kilometer per hour is equal to 5 by 18 meters per second.
Yes, sir.
Fine. 80 kilometer per hour, how many minutes per second? Into 5 by 18. 50 kilometer per hour, how many meters per second? 50 into 5 by 18.
Hmm.
Can we do that?
Hmm.
80 into 5, 400. 400 by 18, how much? We will see. And 50 into 5, 250 by 18, how much we have to see? Yes, na?
Yes, sir.
Just we will see that what will happen. I'll take a calculator. 400 into 18, right?
Yes, sir.
Sorry, 400 divided by 18. 400 divided by 18.
Yes, sir.
22.2.
0.2 bar.
22.2 is okay. Bars not necessary. And 250 by 18.
Hmm.
250 divided by 18. 13.8.
Hmm.
22.2, 13.8. So
Okay.
here 22.2, 13.8. Now acceleration is equal to what is final velocity? 13.8 minus 22.2 by 4 seconds. By 4 seconds.
Hmm.
Yes, now. So
Yes, yes.
again do the calculation. 22.2 minus 13.8.
Hmm.
How much? Generally we can able to calculate over here. 0.4 will come. Here manually we can do, no problem. Again calculator not necessary. What I feel. So 22.2, 13.8, if you do minus, 4 will come. This is 1, 9 will come. Yes. So 9.4 approximately. So
Hmm.
9.4 by 4. How much?
9.4 by 4.
1.6 approximately. So finally acceleration is equal to 1.6 meters per second square, because kilometer per hour we converted into meters per seconds.
Yes, sir.
Got the point? Each and every question, write the given data, required data, then only formula will come. Don't solve it directly.
Yes, sir.
Can we go for the next question?
Yes, sir.
Next, I guess I have to clear the drawing. Yes. Next question. Yes. An
Sir,
electrical. Yes.
there's one thing, sir. But for my exam, there are only going to be MCQ questions.
But even the MCQ questions you should solve, na? If numerical questions comes directly, you can't put tick mark. Let it be MCQ, but you should solve and you have to find out the proper answer.
Yes,
Any
sir.
one of the random answer, don't put it again. That is the one of the reason maybe you are getting less marks. You should answer it. Completely you should answer it. Then the final value, you have to check it up. 4 options, which option may be perfect. MCQ doesn't mean that you can't, without solving you should put tick mark. No. Don't do that.
Yes, sir.
Now, an electrical train is moving with the velocity of 120 km per hour. How much distance will it cover in 30 seconds? Very simple answer.
Yes, sir.
An electrical train is moving with the velocity 120 km per hour. How much distance will it cover in 30 seconds? We will see what is the given data and required data. Velocity how much?
Velocity.
120 km per hour. Time?
30 seconds.
30 seconds. What they're asking? Distance or displacement, anything. Distance they're asking. This is given data, this is required data. 120 km per hour, how many meters per second? Into 5 by 18.
Into 5 by 18.
Yes, na? So 120 into 5 by 18.
18 and 120 will be cancelled.
So 100 by 3, which is
Yes, sir.
33.3
Yes, sir.
meters per second. So time how much? 30 seconds.
Hmm.
Now as per the formula, velocity is equal to
Huh.
distance by time. So distance is equal to
V into T.
velocity into time. So what is velocity? 33.3 into 30. How much it will come? Approximately 999 will come meters. That's it.
Yes. 999. Yes, sir.
Yes.
Yes, sir.
Now I won't show the board to you.
Sir.
I won't show the board to you. Can you answer now? Can you answer this question?
Yes, sir.
Now you tell me, I'll write it over here.
So now the velocity is 120 kilometers kilometers per hour, and the time is 30 seconds.
Okay.
But now we have to convert the kilometer into meter, which is we have to multiply 120 into 5 by 18.
Very good.
So then uh, uh, 8 and 120 will be cancelled. It will be 20. Therefore, it will be 20 into 5 divided by 3, which will be 33.3.
Finally, 33.3. You got it.
33.3 divided by 30.
Why so?
See, 33.3 into 30.
What
Because
is the formula? What is the
because
formula? Don't do that. Don't do that. They won't give the marks to you. What is the formula? Velocity is equal to displacement by time. Without formula, if you solve it, entire the marks will be direct.
yes, sir.
Velocity is equal to distance by time. So distance is equal to velocity. This only carries half mark. For without a formula, they won't give the marks at all. Not for your solution. Formula is the heart of the of this problem. Distance is equal to velocity into time. So what is velocity? 30.3. Time will be 30 seconds. So finally 999 meters.
Yes, sir.
Yes.
Yes, sir. I do know.
Give an example. Each distinguish between uniform acceleration and non-uniform acceleration.
Uniform acceleration and non-uniform acceleration. Non-uniform acceleration. Uniform acceleration and non-uniform. An example of uniform acceleration would be uh, uniform acceleration is when a train goes at constant speed from one place to another. Non-uniform acceleration would be an athlete in a 200-meter track.
My dear, they're asking only examples.
Hmm.
Only examples. Uniform acceleration, one example. Non-uniform acceleration, one example. That's it.
That's what, sir. Like in a uniform acceleration example, it would be when a train is going at a constant speed from one stop to another.
Okay.
And non-uniform acceleration, an example is of an athlete running on a 200-meter track.
Okay. On the time athlete running a track, that will be zero acceleration because circular motion. You can say a non-uniform acceleration Whenever you're going to Wonderla or something, now one tram will be there. Different speeds it will go.
Yes, sir. Roller coaster.
That and all you can say that.
Yes, sir. Yes, sir.
Next. Cut chesema. Next.
Explain the difference between. So first is velocity time graph where where there is equal amount of acceleration. In the second graph, there is the object is
I didn't get.
1 second, sir. 1 second, let me get a proper. Mm, one second, sir. So the first graph, sir, the velocity time graph, first one, the object is going at a speed and constant acceleration, uniform acceleration. In the second graph, the object is not going in a constant acceleration. It yeah.
No. Not like that. First graph will tells that from the zero time onwards, starting at rest, it's a uniform motion. But second graph represents at a certain distance it will go, then again the uniform motion.
Yes, sir.
Not from zero time. Fine. So that's the thing.
Yes, sir.
Next.
Yes, sir.
A particle moves 3 meters north and 4 meters east and finally 6 meters south. Calculate the displacement.
Displacement is equal to velocity by time, no, sir?
Why, sir? You've gone that much distance?
So, 1 second, sir.
Yes.
Yes, sir.
How to solve this answer?
If a 1 second, sir. If a particle moves north 3 meters,
Draw the graph of east, west, south, north.
north, south, east, west. So if the particle moves 3 meters north, 4 meters east, and then 6 meters south. So you would go 1 second, sir. How would you do this, sir? How can you
That's
do
what.
this?
Draw the graph.
Graph meaning
Means x-axis and y-axis.
okay. Yes, sir. True, sir.
Yes. Just you can draw that east, west, south, north.
True, sir.
North, south. This is the way. Fine. Now, along to the direction you draw the graph. An object moves 3 meters north. This is 3 meters north. Then 4 meters east. This is 3 meters top direction. Then east will be right direction is there, na? So this is 4 meters. And finally, 6 meters south, downwards. This is 6 meters. Calculate displacement. Now what is displacement? From here to here. Between these two. How to calculate? Cut the line. If this is 3 meters, what about this? This is also 3 meters, right? Opposite sides are equal.
Yeah, this will be 3 meters.
If this is 4 meters, this is 4 meters. Now total will be 6 meters. This is 3 meters. What about this?
3 meters.
Yes. If this is 4 meter, if this is 3 meter, this is right angle triangle. What about this? Can you apply Pythagoras theorem?
Yes, sir. That will be 7. No, not 7 meter.
Hey, Pythagoras theorem you apply.
Yes, 1 second. How do you get that? Like,
Okay. In a right angle triangle, hypotenuse square is equal to side square plus side square, which is AB square plus BC square. Yes. Now what is AB square? 3 whole square plus BC square 4 whole square. So 3 square means 9. 4 square 16. 9 plus 16 25. So AC square is equal to 25. AC is equal to 5. 5 meters. So finally the displacement is 5 meters.
okay, sir. Okay, so we are going to AC square plus A is equal to AB square plus BC
You forgot that the same questions we solved through PDF. The same thing only.
Yes, sir.
Fine. Next. Next. Yes.
Body can have 0 average velocity, but not 0 average speed. Justify. How do you justify 0 average speed but 0
A body can have 0 average speed, but not 0 average. So sorry. A body can have 0 average velocity, but not have 0 average speed.
How can you have 0 average velocity but not have 0 average speed, sir?
My dear. In this case, if an object travels in a circular path, what will happen? There will be a distance 2 pi r.
Yeah.
But displacement 0, right?
Yes, sir.
Once displacement 0, what about velocity? Velocity is equal to displacement by time. Once displacement 0, velocity also 0. Whenever distance is there, speed will be there. Speed is equal to distance by time. Speed will be there, but velocity will be 0.
Yeah.
Now, which condition? If an object moves in circular path.
An object moves in a circular path.
Yes. Yes, that will be 0.
Yes, sir.
Next. This question. A train 100 meters long, is moving with the velocity 60 km per hour. Find the time taken to cross the bridge of 1 kilometer.
Okay. We have to
This is
find
the
T.
train. This is the train. Okay. The train length is 100 meters. This is the long. It is going with the velocity 60 km per hour.
Yes, sir.
Now there is a bridge. There is a bridge. This distance is 1 kilometer, which means 1000 meters. The train
Okay.
engine came here. The train bogie entered over here. Yes, the train engine starts. If it is engine end, that is 1000 meters. Even the 100 meters of the train totally it has to cross, right? This is 100 plus 1000. 1100 meters the train has to be traveled.
1100.
Because the total bridge length is 1000. Engine to bogie, the train length is 100 meters. This train is crossing the bridge. Initially, engine starts. Again here, engine ends. What about the bogies? This is 100 meters is still is there on the bridge, right?
Yeah.
When it will be crossed, the last bogie has to cross this end. Fine. So this is 100 meter. This is 1000 meter totally.
10,000.
Now, what is the total distance? 1100 meters. Because bridge length plus train length. What is velocity? 60 km per hour. So time taken they're asking. Time is equal to how much? Velocity is equal to displacement by time. Time is equal to displacement by velocity. So 1100, 60 km per hour. How many meters per second? Because this is meters. Sorry?
How many meters?
Meters per second. Because 60 km per hour. How many meters per second?
6,000.
How?
60 into 1000. So it will be.
So this is the way you are doing mistakes. Before numerical I said you 1 kilometer per hour, how many meters per second? 1 kilometer per hour, how many meters per second? See the notes. See the notes. 1 kilometer per hour, how many meters per second? Before numericals we did, right?
Yes, sir.
Put the mind on the paper.
3600.
Hey. I'm not asking 1 hour, how many seconds? 1 kilometer per hour, how many minutes per second?
5 by 18.
Very good. That's it. 5 by 18. That's all I'm asking. So 60 kilometer per hour, how many minutes per second?
Yes, sir.
60 into 5 by 18. Yes, right? Can you solve it?
1 second, sir.
Yes.
60 and 18 50, sir.
How?
See, sir, so 60 and 18 can be cancelled by 3. So when
60
and 18 can be cancelled by 3.
How?
When so 60 can be divided by 3 by 20. So if you cancel 60, it will come as 20. And if you take it, 18 is divisible by 3 also, sir.
Okay. 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 Okay.
So then 20 also you can cancel, it will become 10 by 3.
10 by 3. Okay.
3 divided by 3.
Okay.
What about the 3 on second, sir?
So 50 by 3
50 by 3.
meters per second. Now the same meters per second is substitute here. 50 by 3, which means 1100 into 3 by 50. Right? 1010 cancel over here. And again here 5 2 ja 10. 5 2 ja 10. So 22 into 3, 66 seconds is the answer.
1 minute 6 seconds.
1 minute 6 seconds. It taken time to cross the bridge.
Oh my god, sir.
That is the reason stepwise we have to follow. We can't follow as usually. Now this class is recording. I'll share the recordings.
Okay, sir. Yes, sir. So how much time is over, sir?
Almost over. And I'll give an assignment to you now. Can you solve it?
Assignment, sir. Homework.
Yes.
Okay.
You can solve it. And when is the exam?
Exam, sir. 1 second. 20 seconds, sir.
Okay. I'll solve it. I'll pick that.
Tomorrow I have my social exam.
Okay.
One day gap they're giving, no, sir. So
Not an issue.
after